function. The relation is considered a function when no more than one element of the target set, the independent variables, is associated with each element of the source set, the dependent variables. Function notation. The following function notation is used to show that the dependent variable y is a function of the independent variable x. If we were saying y is equal to 0.25x plus 80, this is in standard notation. If we use function notation or functional notation, it's f of x is equal to 0.25x plus 80. The y is replaced with f of x. We no longer use y. Representing functions. We can represent them verbally, graphically, or with a table of values, or with a rule or an equation. That is in Visions, page 71. Properties of the functions. Domain is the set of all values of the independent variables of a function. That's in Reflections, page 28. The range is the set of all values of the dependent variable of a function, or the y values. Intercepts. Reflections, page 33. The x-intercepts. These are called the abscissa of the points of the graph located on the x-axis. They're also called the zeros. It's when y is equal to 0. The y-intercepts, the ordinate of the points of the graph associated with the y-axis. These are the values at 0 when x is equal to 0. Variation. Reflections, page 37. Increasing. It's the interval of independent values when the curve of a function rises, the x values when the curve is going up or when the graph is going up. Decreasing is the interval of the independent values, the x values, when the curve of the function is going down. Constant. A function that is both increasing and decreasing over a given interval. It's not going up, it's just remaining horizontal, does not rise or fall. Extremes. Reflections, page 40. Maximum is the largest image or y value of the interval if it exists. Minimum is the smallest image or y value of the interval if it exists. We have absolute extremes, we have absolute maximum, absolute minimum, also relative maximum, relative minimums. Signs. Reflections, page 43. Positive is the interval of x values, independent variables, when f of x is greater than 0, when the graph is above the x-axis. Negative is the interval of independent values, or the x values, when f of x is less than 0, when the graph is below the x-axis. The axis of symmetry in Reflections, page 46, a line which reflects a relation onto itself. So we're going to be looking at a temperature altitude graph. The higher you go up, so you're climbing a mountain, the higher you go up, the colder it gets. After a while, you have this little break even. Then it starts getting a little bit warmer till you get to 50 kilometers. Temperature increases till it's about 0, and then it starts to decrease again until you get to 80 kilometers. Then you're kind of into outer space, and so it starts to get hotter and hotter and hotter. Function notation. When is f of x equal to 20, or when's the y value equal to 20? Well, it's equal to 20 here, but it's also equal to 20 there. This one's pretty easy. We can just read it off the graph. When is 10, 20, 30, 40, 50, and the y value is 20, the x is 0. We can just read that off. Or x1 is 0. x2, we're going to have to find out the equation of this line. If I'm going from delta x is here I'm at 80, and here I'm at 120. Because 120 take away 80 from this point to this point is 40. And the delta y is, the y maximum is 100. The y minimum is negative 100. It was 100 minus negative 100, or we've gone up 200 steps. The slope is delta y over delta x, which is 200 divided by 40, which is 5. We end up getting an equation y is equal to ax plus b, 5x plus b. To figure out the b, I'm just going to use 100, 0. It's got a 0 in it. It's going to make it a little bit easier. So the y value is 0. The x is 100. 5 times 100 is 500. B must be negative 500. We keep going down across the y-axis at negative 500. We have this equation, y is equal to negative 5x plus 500. We want to know what the x value is when the y value is 20. Replace the y with 20 and then solve for x. So I'm going to add 500 to both sides. That gives us 520 is equal to 5x. Divide both sides by 5. That gives us 104 is equal to x. And that kind of makes sense. This is 100, 105, 110. 105 is here. 104, that does make sense. Our x2 is 104. And f of x is equal to 20, we get two values. Then they're saying f of 100, when x is 100, they want to know when the x is 100, what's the y? We just have to follow the x-axis to 100, and the y is 0, okay? f of negative 100. When x is negative 100, notice we don't have that on here. It's not on our graph. When x is negative 100, there is no value. The domain is all the x value. We're starting at 0 and we're going to 120. So the domain is x is a member of 0 to 120. The range are all the y values from the lowest y value, which is negative 100, to the highest value, y value, which is positive 100. f of x is a member of negative 100 to 100. The intercepts, the x-intercept, where Where does it cross the x-axis? Here, here, and here. We have 3 of them. The first one, we're going to have to use an equation to solve to figure out what this point is. Looks like it's 2.5. I'm going to figure out my delta x. My delta x is 10. My delta y is, this is negative 60. That's 20. So negative 60 minus 20 is negative 80. And that gives us a slope of negative 80 divided by 10, which is negative 8. Our b value we know is 20. That gives us an equation of y equals ax plus b, which is negative 8x plus 20. We want to know what the x value is when the y value is 0. So replace the y with 0 and then solve for x. Subtract 20 from both sides. That gives us negative 20 is equal to negative 8x. Divide both sides by negative 8. X is equal to 2.5 as predicted. We're getting 2.5 here. Here, we can just read it off. It is 50, and here it's 100. The x-intercepts are 2.5, 50, and 100. The y-intercepts are, where does it cross the y-axis? Well, it only touches the y-axis here at 20. All right, variation. When is it increasing? It's increasing here and here. When x is a member of 25 to 50, union 80 to 120. It's decreasing here and here. When x is a member of 0 to 10, union 50 to 80. When is it constant? It's constant right here. It's constant between 10 and 25. The extremes, the maximum, the absolute maximum would be 100 when f of x is equal to 100. The minimum would be f of x is equal to negative 100 right here. The relative maximum, this one, when the y value is at 20, f of x is equal to 20. But also you could say this one as well, when the y value is at 0. And then relative minimums would be, this is the other low point, the next lowest point, that's negative 60. F of x is equal to negative 60. The signs, when is it positive? Well, the graph is positive from here to here. When x is a member of 0 to 2.5 and here to here, from 100 to 120. When is it negative? It's negative from 2.5 all the way up to here, but 0, remember, is both positive and negative, so we can include this all the way up to 100, from 2.5 to 100. Axis of symmetry. This is not symmetrical. There is no axis of symmetry. If you had a parabola that looks something like this would be your axis of symmetry along the line. X equals 3 would be your axis of symmetry. Or if you had a sine wave. So if you had a sine wave that looked like this, your x-axis would be your axis of symmetry. All right, and that's it for function notes. Have a good day.